So for our final topic, we discussed power sets. So remember, we're going to start with our definition of what a power set is. It's the set consisting of all subsets of a given set is called the power set of A. And the way we denote it, denoted by a P of A, means the power set of A. So what I want us to do is see, we're going to look at two power sets in our example. So I want you to look at the power set of A minus B and the power set of A union B, and I want you to tell me how are these two sets related. And so you're gonna start by looking at an example to see how are these sets related. So we need to pick a set A and we need to pick a set B. So let's say set A is the set 1, 2, and because we're going to look at A minus B, I would like for these to overlap, so maybe the set 1, 3. All right, so now that I have my two sets picked out, I'm going to look at the set A minus B. That would just be the set 2. A union B, that would be the set 1, 2, 3. And now I need to write out the power sets of these sets. So the power set of A minus B, it's just the empty set and the set containing 2. And the power set of A union B will be the set containing 1, 2, the set containing 3. Then all of our subsets with 2 elements in them, 1, 2, 1, 3, and 2, 3. And then 1, 2, 3. All right, so now I can look at my example and I see that all the elements in the first set are also in the second set. So my guess is that the power set of A minus B is contained in the power set of A union B. And now what I want us to do is I want us to prove it. We looked at an example and this is our conjecture, but now I want us to prove this. So again, we're going to outline our proof. So the outline of our proof, the start, I need to take an element out of my power set of A minus B. And remember, the elements of our power sets are sets. So I'm going to choose C, capital C, when I talk about sets, C to be in the power set of A minus B. And then in the end, I need to say that C is in the power set of A union B. So down here, the end of my proof will be that C is in the power set of A union B. Well, remember, the elements in the power set are subsets of the set. So this means C is a subset of A union B. Okay, let's go back here. Again, to be an element of a power set means you're a subset. So C is a subset of A minus B. And here's where you're going to have to look back at your end. What do I need to prove in the end? I need to prove that C is a subset of A union B. So I'm going to start with an arbitrary element out of C. And I'm going to show that that element X, it needs to be in A union B. Well, we know that C is a subset of A minus B, and X is in C, so I can now say that X is in A minus B. Well, but that tells me X is in A and X is not in B. What did I need to say X was in? I needed to say X was in A union B. Well, look right there. I have X is in A. That means that tells me that X is in A union B. So I've proven that C is a subset of A union B, which is exactly what I needed to get to. Right there. That's what I needed to get to, and that's what I did. So now all you've got to do is take this outline of your proof and write a formal proof from it. Now, we did show that the power set of A minus B was a subset of the power set of A union B, but our example earlier helped us see that the power set of A union B is not a subset of the power set of A minus B. And this is by our counter example from earlier. So these sets aren't equal, but they do have, but one of them is a subset of the other.